Okay, so now what we're going to do is we're going to move on to, there are some restrictions to rational functions. For one thing, if one restriction is that you cannot divide by 0. This is a no-no. So with that said, let's say if we had, for example, 16 over 6n minus 12, okay? We want to find the values of n that you cannot include. And we know that the denominator here cannot equal 0. So we write 6n minus 12 cannot equal 0. So now we have to find what n is. So we just solve it like a regular equation. So we isolate the variable, so we get 6n is not equal to 12, or cannot equal 12, and then n cannot equal, to 2. Yeah, so n cannot equal to 2, otherwise you're going to get a 0 at the bottom. Let's try a couple others. We have 4x squared. Alright, then we have 14x squared minus 16x. Again, let's focus on the denominator. So we have to think about numbers that will equal to 0, okay, and then we have to exclude those. So here, if we take this factor, 14x squared minus 16x, we can factor out an x here. Alright, then we have 14x minus 16. Okay, so we know that x already cannot equal 0. Okay, and then here, let's solve for x. Alright, so 14x cannot equal 16. So x cannot equal 16 over 14, which is also equal to, so we can factor 2 and 7, 2 and 8, so 8 over 7. So x cannot equal 0 or 8 over 7. How about a couple others? Alright. What if we had something like 15p squared minus 24p? Alright. Divide that. Let's see. We have 21p cubed plus 33p squared plus 12p. Okay, so now we focus on the denominator. So this thing cannot equal 0. This monstrosity is trinomial. Okay, so what we do is we see if we can factor any stuff out. And if we can, then let's do so. So can we factor out any coefficients here? Well, let's see. You get 21, 33, and 12. So we're trying to find a common factor for all three of them. So let's see. 7? No. How about 3? 3 is a factor of 21. 3 and 12. Are there any bigger ones? No, there aren't. Let's factor out a 3. We can also factor out a p, right? Because it will have a p in common. So we hit 7p squared plus 11p plus 4. Alright? Is that right? Yes, it is. Okay. So now, let's try to find the factors of this trinomial. So we create two binomials. Let's say this is 7p and then p. Alright. Now we want to create something where we can get a factor of 11. So let's see here. Can we? Well, yes we can. So 4 and 1, because we know that 7 times 1 is 7, and then 4, and then if we add those two together, 7 plus 4 should equal 11. So we'll put a positive sign. Okay? Alright, so now let's find the values of p. So 7p plus 4 is equal to 0. or cannot equal 0 in this case, and p plus 1 cannot equal to 0. This is the easier one, so p cannot equal to negative 1. And here, okay, 7p cannot equal to negative 4 because we can get the 4 over, so p cannot equal to negative 4 over 7. Alright, and there's one final one because we didn't count for 3p, so p cannot also equal 0. So there's three answers. It cannot be 0, negative 4 over 7, or negative 1, or else this fraction will not exist.